In this video, we are going to create an expert advisor that utilizes the Trix indicator for trading decisions. Let's see how we can do that. We start Metaeditor by clicking a little icon or pressing F4. The first part of our code includes the CTrade class from the standard library. This class provides simplified trading methods, such as PositionOpen and PositionModify, which we will use to manage our trading operations. We instantiate a CTrade object named Trade, which will handle all our trading operations, including position management. Next, we define our strategy configuration parameters. These parameters can be adjusted in the Expert Advisor properties. The LookbackBars parameter is set to 50, which indicates the historical range for highs and lows that we will analyze, allowing us to look back at 1 to 1,000 candles. The MinCandlesBack parameter is set to 5, meaning we require a minimum age of 5 to 50 candles for valid highs and lows. The TrailingOffset parameter is set to 10.0, which defines the safety distance for the trailing stop in points, with a range of 1 to 20. The TrixPeriod parameter is set to 14, which specifies the period for the Trix indicator. Finally, the TrixPrice parameter is set to price close, indicating that we will use the closing price for Trix calculations. We then declare some global variables and handles to store the state between ticks and indicator data. The Trix handle variable will hold the Trix indicator handle, while TrixBuffer is an array that will store the Trix values. The price data array will hold the open, high, low, and close price data. We also have two Boolean variables, prevBullish signal and prevBearish signal, which will track the previous state of bullish and bearish signals. The onInit function is executed once when the expert advisor starts. In this function, we create the Trix indicator handle using the built-in function iTrix. We configure the TrixBuffer and price data arrays as time series, ensuring that the newest data is at index 0. This alignment allows us to work with the data in a natural time flow. Finally, we return the success code in it succeeded to indicate that the initialization was successful. Next, we define functions for opening positions. The openByPosition function is responsible for executing a buy order. It retrieves the current ask price using the symbolinfo_double function and then calls the PositionOpen method from the CTrade class. The parameters for this method include the financial instrument symbol, the order type set to order type buy for a long position, the position size of 0.10, which means we are buying 10 micro lots, the entry price at the current ask, and both the initial stop loss and take profit set to 0, indicating they are disabled. A comment Trix position is also included for identification. The openSellPosition function operates similarly but for sell orders. It retrieves the current bid price and calls the PositionOpen method with the order type set to order type sell for a short position. The parameters are the same as in the buy function, with the position size still being 0.10 lots. The onTick function is the core logic of our strategy and is executed on each tick. In this function, we first retrieve historical price data for analysis by copying H1 candle data for the lookback period using the copyRates function. The parameters include the symbol, time frame, starting position, count of candles to copy, and the target array where the data will be stored. We also load Trix values from the indicator buffer into the TrixBuffer array using the copyBuffer function. Next, we check the status of open positions. We initialize a Boolean variable has open position to false and set the current position type to position type by as a default value. We then iterate through all open positions in reverse order to find relevant ones. For each position, we get the unique ticket number and check if it belongs to the current symbol. If it does, we mark that an open position was found and store the type of the current position. We exit the loop after finding the first matching position. We then check for Trix signals. A bullish signal occurs when the Trix crosses above 0, which we determine by checking if the previous Trix value was less than 0 and the current Trix value is greater than 0. Conversely, a bearish signal occurs when the Trix crosses below 0, indicated by the previous Trix value being greater than 0 and the current Trix value being less than 0. If a bullish signal is detected and there was no previous bullish signal, we check if there are any open positions. If there are none, we call the openByPosition function to open a new buy position. If there is an open by position, we identify the lowest low in the lookback period using the iLowest function. We also check that the low point is at least MinCandlesBack old and that the current price is above the identified low. If these conditions are met, we calculate the trailing stop level by adding the trailing offset to the last low price and call the ProcessTrailingStop function to manage the trailing stop. For a bearish signal, the process is similar. If a bearish signal is detected and there was no previous bearish signal, we check for open positions. If there are none, we call the open sell position function to open a new sell position. If there is an open sell position, we identify the highest high in the lookback period using the iHighest function. We check that the high point is at least MinCandlesBack old and that the current price is below the identified high. If these conditions are met, we calculate the trailing stop level by subtracting the trailing offset from the last high price and call the ProcessTrailingStop function. At the end of the onTick function, we update the previous signal states for the next tick by assigning the current bullish and bearish signals to prev bullish signal and prev bearish signal. The ProcessTrailingStop function is responsible for managing the trailing stop for both buy and sell positions. It loops through all open positions in reverse order for safe changes. For each position, it selects the position by ticket number and checks if it matches the specified position type and belongs to the current chart symbol. If it does, we retrieve the current stop loss value. For buy positions, we check if the new stop level is higher than the current stop or if there is no existing stop loss. If either condition is true, we call the PositionModify method to update the stop loss. For sell positions, we check if the new stop level is lower than the current stop or if there is no existing stop loss. If either condition is true, we also call the PositionModify method to update the stop loss. Finally, we press F7 to compile the code. If this was too fast for you or if you don't understand what all the code is doing, you may want to check out the premium course on our website or watch one of the basic videos first. If that works, we go back to Metaeditor by pressing F4 or clicking on the icon. Back in Metaeditor, we press Ctrl and R to start the strategy tester, pick the expert advisor that we have just created, enable the visual mode, and start a strategy test. We should see the expert advisor on the chart. If you are already a premium course member and have an idea for a video like this one, you can send us an email. In this video, we have learned how to code an expert advisor that utilizes the Trix indicator for trading decisions. We have implemented a few lines of MQL code to create a functional trading strategy. Thanks for watching, and I will see you in the next video.